Hi, welcome to another lab note session. In this session, we are going to discuss access control list on ASA. Here is our topology. We have 5 routers, 1 ASA, and 4 security zones. We have inside, outside, DMZ, and WAN zone. We have assigned 100 security level for inside, 0 security level for outside. DMZ and WAN zone have security level of 50. We'll be using 192.168.1.0/24 for outside, 192.168.2.0/24 segment for DMZ, 192.168.3.0/24 for inside, 192.168.4.0/24 for WAN zone. We aim to complete few tasks in this topology. First thing, traffic from same security level zone. We will be testing SSH access from R4 to R2. So R2 and R4 are in same security zone. Second task, traffic from lower security level to higher security level. We will be checking SSH access from R4 to R3. R4 is having security level of 50 and security level 100 is on R3. Then DNS and Icmp traffic. We'll try to resolve DNS query like from R5 we'll try to ping dns.google.com, which is supposed to resolve to 8.8.8.8, which is configured in R1's loopback 0 address. So when we ping from R5, that DNS name has to get resolved from R3 and it has to reach from R5 to loopback address of R1, and the ICMP response has to reach back to R5. So these are our tasks. So let's start doing this lab. First we'll make some initial configurations. So let's bring up R1. Enable configure terminal, host name R1. We need to assign IP address. So R1's 0/0. In the topology you may see gig 0/0, but in similar it is fast Ethernet. So 192.168.1.1/24 is R1's address. Fast Ethernet source. Loopback 0 IP address 8.8.8/32 will assign. Then I need to create a static route stating 192.168/16, which will be routed to ASA. This is to route the response back to R5. We are in R2. Hostname R2, folder is also 0. So R2 is in DMZ zone, and it have IP address 192.168.2.1/24, and I need to create one static route. It will be a default route towards ASA. Let's configure R3. Hostname R3. Interface fast Ethernet 0/0. IP address 192.168.3.1/24. And a default route towards ASA. Let's go to R4. Hostname R4. Interface was 192.168.4.1. R5. Enable configure terminal hostname R5 interface faster than 0/0 192.168.4.2/24. Then IP route. Oops. Now ASA. So in ASA, enable show interface IP brief. We have 4 Ethernet interfaces. So the physical connectivities, actually in topology it's a G0/0, but in reality it is Ethernet 0, which is connected to outside router 1, and Ethernet 1 is connected to router 3, which is inside. Ethernet 2 is connected to router 2, which is on DMZ, and Ethernet 3 is connected to a switch, which is going to R4 and R5. Interface Ethernet 0. Let's configure IP address 192.160 IP address 192.168.1.100.525.5.0. Then name if, which is outside. So it has taken security level of 0, that is default behavior. Now shut. Now let's go to inside interface, which is Ethernet 1, IP address 192.168.3.100/24. Name if. Inside. It has taken security level of 100, that is default nature. So now shut. Then let's configure DMZ interface, which is Ethernet 2, IP address 192.168.2.100/24. Name of DMZ. So it has taken security level of 0. Yeah, only for inside interface it will assign security level of 100 by default. Remaining everything is will assign as 0. So according to our lab, we need to configure 50. Ethernet 3, that is IP address 192.168.4.100/24. Name if. WAN zone. Security level 50. Oh shit. So let's ping all connected interfaces. I'll show you. Show name if. You can see we have assigned Ethernet 0 on outside, Ethernet 1 inside, Ethernet 2 DMZ, Ethernet 3 WAN zone. Security level up, respectively, you can find here. Show interface IP brief. You have assigned 0 interface is for 1 segment, then 2 is for, yeah, we are good to go. So let's check Icmp reachability with connected interfaces. Okay, so now we can reach R1, R2, R3, R4 and R5. Now I need to make one more thing, which is a default route from ASA. So I am considering our outside interface is connected to internet. So it's a route outside. Either we can type 0.0.0, but then subnet also 0. So otherwise we can type like this 0 as 0 space 0, or the normal default route also we can mention like that. So it's towards R1. Yeah, so in this topology we are telling R1 is our ISP and a default route towards internet. So now we can check the task. So the first task, traffic from same security level zones. Configure ASA for SSH from R4 to R2. So basically we need to have SSH access from R4 to R2. That is the task number 1. Let's enable R2. R2's SSH. Yeah. First we'll enable SSH on R2. Username admin, privilege 15, password let's use secret, CISCO, IP domain name cisco.com, crypto key generate ASA modulus 1024, LAN VTY 0 to 15, transport input SSH, login local. Now we have enabled SSH on R2. So before performing any task, I would like to enable logging on ASA so that we can understand what is happening. This I'm doing for our learning purpose. Let's bring R4. So we are going to perform SSH from R4 to R2. So that will be like SSH and 68.2.1s.s. So you can see that inbound TCP connection denied from 192.168.4.1 and the source port is 61724, which is trying to reach 192.168.2.1, which is R2 on destination port 22, and the flag is SIM on interface WAN zone. So what we can do in this case, either we can write an access list permitting this traffic. Other thing, when we analyze the security level of the source and destination, both are in same security level zones. So we have one option, it's a global command. It's not mandatory to do, it's an optional. So I would like to enable same security level traffic permitting. So the command is same security traffic permit. There are two options, inter interface and intra interface. In our case it is inter interface. If R4 was trying to reach R5, then it will be intra. R4 is trying to reach R2. So we need to permit interface. Now we can verify. So right now I'm going back to R4 and trying to do SSH on R2. Now it is asking for the password. Yep, now I'm in R2. I have SSH R2. So this is what these denies you can make. Now let's check the second task, traffic from lower security level to higher security level. Configure access list for SSH access from R4 to R3. We need to do SSH from R4 to R3. So R4 is sitting on security level 50 and R3 is sitting on security level 100. So before making any change, let's check what is happening when we try to reach R3. First thing, we need to enable SSH there. Enable, configure terminal, username admin, privilege 15, secret CISCO, IP domain name cisco.com, crypto key, generate ASA modulus 1024, line VTY 0 to 15, transport input SSH, login local. Now we have enabled SSH on R3. We'll try to reach R3 from R4. So you can find inbound TCP connection denied from 192.168.4.1 on source port 19125 to 192.168.3.1 on destination port 22, and flags same on interface WAN zone. So in this test we need to write an access list. So let's go to ASA. We'll write an extended access list. So access list, we need to have a name. So show name if I normally prefer interface name. So this is WAN zone because my source is WAN zone. Access list, WAN zone, permit TCP, it's a TCP traffic, so TCP. Then we need to mention the host, source host, which is 192.168.4.1 is R4's address because we are trying from R4. Then destination host 192.168.3.1 is R3. Then destination port 22. Even we can mention source port also, but that is a random port. There's no point trying on source port. So this is the best way what we can do. So the destination port will be the same, it is 22. We have created access list. We need to apply on right interface. So access list, access group, WAN zone, inbound traffic, interface, WAN zone. That's it. Now we can verify whether we are able to perform SSH from R4 to R3. Yeah, it is asking for the password. Now yes, we have reached R3. So the second task also done. Now the third one, DNS and Icmp traffic. Configure ASA to resolve internal DNS queries from R5 to R3. R3 is the DNS server. So first thing, go to R5. We need to mention which is our name server. So domain lookup, anyway it's enabled by default. So IP name server 192.168.3.1, that is our DNS server. Now we need to make R3 as DNS server. IP DNS server IP host. We need to resolve dns.google.com, and this belongs to this address. This is the resolution, should be okay. Let's bring ASA and R5. We'll try to ping dns.google.com. We can see DNS UDP source on WAN zone 192.168.4.2, that is R5, and source port 52497, and destination is inside interface, and the destination address is 192.168.3.1, and the destination port is 53. So it is denied by access group WAN zone. We need to permit that. So access list WAN zone permit, it's a UDP source host 192.168.4.2, destination host is 192.168.3.1, and the destination port is DNS, it's 53. Yeah, so when we ping, before configuring access entry, it was just trying to resolve the name by contacting domain name server. So it got an error, unrecognized host or address or protocol not running. Now let's see what is the response. Now it got resolved and sending 100 byte Icmp equals to 8.8.8.8, and it got timeout. And in ASA we can see that DNS Icmp source 192.168.4.2, which is trying to reach destination address on outside, which is 8.8.8.8. This traffic is blocked by access group WAN zone, so we need to permit that. access list, WAN zone, permit, it's Icmp, and the source host is 192.168.4.2 is trying to reach destination host 8.8.8. That's it. Now let's try. We are pinging dns.google.com from our file. So now it is telling build outbound ICMP connection for further 8.8.8. Yeah. Then it got denied inbound ICMP source from on outside interface. The address is 8.8.8.8 and the destination is WAN zone interface 192.168.4.2. So what is happening? R1 is sending the traffic, but it's not getting permitted on ASA. We can verify that, which is debug IP ICMP. So now we have R1 debug enabled and ASA in the background. Let's see. R1 is sending the ICMP response. Echo replace sent, source is 8.8.8.8 and destination is 192.168.4.2, but ASA is denying. So we need to permit that. So we need to write another access list outside, because it got denied on outside interface. Outside permit ICMP from source host 8.8.8 and the destination host 192.168.303. 4.2 is R5's address. That's it. Now we'll apply this access list, access group, outside, inbound, interface, outside. Now let's verify. Yeah, now we can ping dns.google.com. So this is our small topology. So we have checked how to write an extended access control list. So I hope you have understood the concept here, and I would like to thank you for watching.